Okay, hello everybody. Welcome to Build. How you doing? Woo! There we go. Yeah. For people watching back home, the audience is filled. It's massive. Everyone's excited, so it's all good. Right. So my name's Martin Woodward. I'm from the GitHub team, joining you today, and then I have with me as well Facundo. So Facundo.
Hello everyone. My name is Facundo Santiago. I'm a principal product manager in Azure AI Foundry. Happy to be with you here.
So what we're going to be doing today is we're going to dig into a couple of different things. We're going to really show you what it's like to be a developer building on top of large language models, foundational models. And we're going to kind of drill in, go throughout the whole thing, go across the whole life cycle. Quite a lot of demos, so we're going to dive in pretty quickly and get started. But really, it's just kind of give you a taste of all the different parts. The reasons why I wanted it at the beginning of the week is so you've got time to see which bits interest you and then go and grab some other sessions if you want to dig into any particular area. So that's the plan. Hopefully everybody's in the right session and we'll get started. Okay, fantastic. Right, so first of all, if we look at like AI in general across the whole DevOps pipeline, we're seeing it massively like accelerate how we build things in general. So I work on a lot of the dev tool side, and we're seeing, getting code from idea to production has got faster, but then importantly, like learning. So getting ideas and stuff from production back into development and doing that whole loop. That's just accelerating more and more with the use of AI tools during development. But what we're going to talk about today is how you build AI into your applications. So that's the point of this session. When we look at sort of trends in the industry, we've got the receipts down at the bottom, and you can download other slides and go look up all the reports. But actually, I guess the reason why most of you are here is this first stat, that 81% of leaders in different organizations think their company, they'll be integrating AI into their company strategy in the next 18 months. So who here is here because they're at the point where they're about to start integrating large language models and LLMs into their applications? Okay, cool. Who's already doing this? Who already building on top of? Wow, cool. So that's about 50%, 50-50, so this is great. As we see, of those people, 93% are actually experimenting with multiple models, not just linking to one model. We'll talk about why that is. And then 70% have been experimenting with generative AI, but have not managed to make it through into production yet, which is a fascinating stat. And what we want to do is get that down to 70% of them make it into production by the end of this session, hopefully. So if we look at the way that we build applications, for a living, both Facundo and I we build the products, but we also do a lot of demos on top of our applications. And as you saw in the keynote this morning, doing demos on top of large language models can be fun because they're not deterministic; they're probabilistic. They deliberately have an element of randomness in there that gives slightly different answers and things. So learning how to build those types of applications has changed a lot. The way that you write your code, you're writing kind of semantic C# or Java or whatever code, Python, whatever code you're writing. When you're doing work with LLMs, you find yourself adjusting and tweaking prompts and trying to improve your prompts for that large language model. And the large language models are just moving faster and faster. And so, you talk to one version of GPT-4, and then next week you've got a different version to be talking to, and you notice tweaks of the prompts help improve things, and you're constantly evolving. With traditional other applications that we build, you're obviously building features, you're delivering, but with intelligence apps, you can build agents to help you build that functionality, and we're going to dig into that. And then last but not least, there's obviously, you need to do lots of testing when you're building applications, that's good, but you need to do this even more so when you're building intelligent applications. You need lots of testing in there at every level. So you need testing when you're doing evaluations of models. You need testing during the life cycle to ensure you're still getting the performance you need. And then you also need testing of the whole end-to-end processes and all the security testing as well to make sure nobody's trying to inject stuff into your applications and things. When we look at actually building these types of applications, we kind of see 3 phases, fairly traditional phases, but it's like a design, a customize, and then a manage phase. Because remember, you're working against usually a model hosted by somebody else that you're using the infrastructure. So you start off by experimenting, by having hypotheses, finding the right models. You then move into a customization side where you're switching between models, you're switching between your prompts, customizing your prompts, or maybe you're looking at fine-tuning some results, I'll say. We can talk a bit about like fine-tuning models versus fine-tuning prompts and fine-tuning RAG and things. And then you get into the deployment phase and managing, and how do you actually manage one of these services when it's in production? How do you stay up to date? How do you work with that? Now, I work on the Copilot side. I work at GitHub, so we work on GitHub Copilot. Been involved since the very, very first days. I was like number 6 on the team of working on Copilot sort of thing. So I've been involved from the beginning. And it's been through a lot of change in that time. I used to have hair when this process started, No, it wasn't. No. I wish. It feels like I've packed in about 50 years into the last 2 years. But anyway, it's been very busy. But we learned a few things. The first thing that we learned really is around you need to do a lot of iteration and on your prompting. You're constantly iterating and tweaking those system prompts and improving them. And we do a lot of A/B testing. The only telemetry that GitHub collects from you when you're using GitHub Copilot is, well, the majority of the telemetry is around code, is acceptance. Did you find that result helpful or not? Did you use that result? And that's how we test if we've made our system prompts better or worse, by did we manage to make the acceptance rate go higher or lower, So we can do A/B testing. We can send the same prompt data in that's coming into 2 different models and see what results come back with real-life prompts and things, as well as synthetic prompts and benchmarks. We are constantly evaluating that base model. We're constantly taking the models that we use and evaluating new models. You saw in the keynote today, like Grok 3 has been added to the model catalog. We've added other models as well. We're adding models all the time, and we're trying to get to the point where we sim ship the models, so when they're available from the large language model provider. Facundo's team have usually been talking to them like a week or 2, like literally a week or 2 before sometimes. Or like quite often it's like the weekend before it launches, we still don't know what it's going to be called and things. It moves very, very fast. And then we're working with them as well, because GitHub Copilot uses the Azure AI backends. And then once we have the model available, as soon as it ships that day, we do a final pass through all of our benchmarks, a final pass through all of our tests to make sure this is still looking good. And then we get it live and we allow people to start using it in preview and see how that goes. Like that kind of turnaround is just ridiculous. When I started work at Microsoft, it used to take us 9 months to ship anything, and nothing changed. The minimum time you could get it to customers was 9 months. And now we frequently, 9 days would be lovely, wouldn't it? 9 hours is sometimes what we're working on from actually us having it in our hands. So it's crazy. And then also you find that each of these models work slightly differently. And so quite often you want to customize your system prompt for each model, really. So we'll talk about that. Now, when I go talk to customers, and when I'm going to talk to customers, we see some common trends, as well as the trends that we see when we're building Copilot. This ability to be able to prototype quickly, the way of doing kind of easy experimentation and testing, and then obviously you need the security of a stable platform. You also need to do things responsibly. You need help with filtering. You need help with all of the infrastructure you need to put in place. Because just like when you were doing normal coding, you need to have a sort of combative mindset in terms of how you are approaching your code. You need to do the same thing when you're using large language model applications, because your interface, your input interface, is a much larger surface area. Say you're giving somebody a chat window, it's not just 1 or 2 things you have to validate against. They can type any code in there, any language in there that they want. And so being able to think about how they can try and corrupt the way that you're processing this data. Maybe if you're taking inputs in from by email and then processing them in an agent and then outputting things. If people do prompt injection into the inbound data and all that sort of stuff. Like all of these things you have to kind of factor in, and we have infrastructure to help you on the security side. Now I'm going to dig into GitHub Models. This is brand new today. like literally just shipped this morning in the keynote. If you go into your GitHub orgs, you can enable it for your GitHub organization if you're the org admin, or you can go enable it yourself as well if you want on personal accounts. It adds a new tab into your GitHub interface. We are bringing models as a first tier into the GitHub UI. So that's how important we think models are going to be for everybody. It enables you to experiment, enables you to use code, prompts as code, and it also allows you to do kind of side-by-side evaluation of these models straight from where you are in GitHub. You don't need to sign up for an Azure account. You don't need nothing. You don't need to go, and remember we're collecting models from lots of different providers. You simply have a GitHub login, and you can use GitHub models and go experiment and start to learn today. So if your boss is saying to you, hey, how can large language models help me? It's not an excuse anymore to say, oh, well, I've got to go do all this stuff and set up all these things, and I've got to go to legal and get them to approve a bunch of invoices. No, you just need a GitHub account, and you need to accept the preview conditions, which will take you a few conversations with legal. But anyway, it's getting easier. So what I'm going to do is just kind of placeholder it with my demo placeholder slide, which I forgot to change the language of, so that's awesome. Right, number 2. Hopefully, is that a black screen for you too? That's exciting. Let me just fall back. 1 second. Can I borrow your input a second?
Yeah.
Sorry.
Okay.
Oh, there we go. It's going to work. Right, okay. And we're going to have to do it the old-fashioned way.
I think it's...
Woohoo! Right, so we can't blame the AI for that one, can we? Right, okay. So this is our travel application, and you can see here I've got this models tab now because I've got it enabled on my repo. So that's great. So I'm going to go have a look at it. The first thing when you come in, you can have a look around. So you're all, like 50% of you are in kind of early experimentation stage. What can I actually do? So within this models tab is actually a playground where you can go play. So for example, we've just seen that we talked, like in the keynote, I think there you go, Grok 3 shipped this morning. I've never used this yet. This is literally going to be my first time using it. Let's see what Grok 3 can do. I honestly haven't used this yet, so let's find out. So I'm going to say, write me a poem about coming to Microsoft Build 2025. Make it short, because, I'm packing my dreams, heading to the scene. Microsoft, this is pretty good. Cool. Yeah, that'll do. Good job, Grok. Okay, so you can see how it can do stuff. You can see how it can be a model. What I'd quite like to do, though, is play with some models that have, say, got some multimodal capabilities, because maybe I want to try out what you can do with images and things. So I'm going to come in here, and I'm going to bring up a prompt. I'll attach an image from a camera roll. There we go. There's a nice image of me with a cardboard cutout of me that my teammates did for some bizarre reason, probably to play darts. And then I'm going to come in, and I'm just going to say, how many people are in this picture? Because it's an AI, this will be exciting. Let's see what it tells me. So I'm going to ask GPT-4 with this picture, how many people are in it? Oh, that is amazing, actually. So it can, one person and a life-size cardboard cutout of a person. But how does that compare? Because GPT-4.1 is like one of the most up-to-date kind of models. It's fast, it's really, really capable. Let's compare that with a different model. So I'm going to compare that with, say, 535 Vision. So these Phi models are quite small models. They run, with low area. They're much smaller, but they're still quite capable, surprisingly so. So let's come in here, and we'll actually attach an image again. And I'm going to do exactly the same. Oh, no, I'm not. I'm showing you what I'm about to do in a second. I'm going to do exactly the same prompt. And then notice when I'm doing compare, using the same prompts in 2 different models, I can hit enter and see what the results are. Now, you notice I got back a result really, really quickly from 535, and I got back a result a bit slower from GPT-4.1, but GPT-4.1 was smarter in that it knew one of them was a cardboard cutout, whereas 3.5 said there's 2 people. And so you can now make these decisions about which is the right model for my job. Don't be fooled into thinking, well, I'll just use the most, like the one with the most reasoning, the most power, because they're usually the most expensive to run and take longer to give you back a result. If counting 2 for this particular answer was good enough for you in your application, use the lowest spec model you can get away with for the job. If you're doing text summarization, every model can do a really good job with text summarization, so why use a really big, expensive, powerful model? Can I use a cheaper model? And that's part of this constant iteration that you need to be doing as engineers for your teams. Brilliant. So that's kind of the playground, which existed before in like a marketplace experience of people that have played with models. We've got some more stuff now as well. I can go into my overview, and what I can see here is it's found the prompts I'm using as part of my application. Now, with this application we're in here is a demo one we've got for like doing travel, flight bookings, that sort of thing. But we can see I've got a number of prompts, like for instance, this cities prompt.yaml. And here it's saying you're a travel advisor, based on this, suggest a city. So, and then we've noticed here as well, we have the ability to specify input. So I can give it a prompt and I can wrap it and say, hey, this is the bit I'm going to change between every invocation kind of thing. You know, like you do with stored procedures where you like mark a variable, that sort of thing. Do the same sort of thing here. So I'm going to run this, but I'm first going to set some variables. So, you know, Huge Park shopping and hot dogs is what I had. But let's write something that's a bit more typical of a human response. So, for example, every time I wake up in the morning, I like to remind myself that I am 1 year younger than David Beckham, which is a true fact. Where should I go to see him, George Clooney, and Sandra Bullock? There we go. Cool. Classic show my age with my references. And I've got a bunch of typos here and all that's good because that's natural user data. I'm going to hit run and see what response it comes back with. Instantly comes back and tells me to go to London, which is exciting. I would have probably thought it would tell me to go to Los Angeles. So let's press run again. Oh, look at that. And so that's interesting. Going to press run again. And so we can see there is some kind of like, you know, variance in that data, but more often than not, it's going to give me one particular answer. So maybe what I need to do is play with my prompts to get the answers that I want. And that's part of kind of the experimentation. You notice I have a compare tab here as well. And to me, this is like one of the killer features of this, you know, this current preview. And remember, this is just the preview that we're showing you here. This is like for early use for you to try and get some value from, tell us how you like it. So what I can do now is I can take my prompt and I've gone in, and I'll show you how I did it, but I've gone in and added a bunch of test data. So I've said Huge Park shopping, I've said CN Tower ice hockey. Like I've given a bunch of test data here for it to use, and I can add additional data if I want. I can import some. But what I'm actually going to do is I'm going to add another prompt, and I'm going to copy it from my original. And then when you're doing prompt engineering, what you want to do is it's like any form of science, you know? You want to change one variable and see what the outputs usually are, because you're doing probabilistic stuff now. You're not doing strict, you know, deterministic. So usually what you do is I'll take my system prompt, and then the system prompt, like I'm going to tweak my system prompt and I'm going to compare them. I'm going to do those A/B tests and see which is best, you know, or I'm going to compare a bunch. Or what I could do as well is I can change the model. So rather than GPT-4o, let's use a much smaller model, GPT-4o mini. And then maybe while we're here, let's do that again, and we'll also add in, say, something like, we'll use one of the Phi ones again. So let's go with like that tiny context model one. We'll do 5.3 like with a tiny context model, and we'll see. Oops, sorry, I forgot to tick it. 5.3 small instruct. Great. So we'll compare those three models. And we'll just hit, well, as well as similarity, I can add a number of evaluators into the mix. So I can come in here and I can say similarity, which is, you know, how close it is to the predicted answer. I could also add groundedness. So how much is my model just making stuff up? The reason, if you see hallucinations, that's because you've not given adequate grounding to your model. You're not giving it the data it needs in the context to be able to give you an answer. So we're going to add an evaluator that tells us how grounded the answer is. And then we've got other ones. We can do a simple string check. You know, does it contain this string, for example? Or you can even write your own LLM-based tests for your model. So you can look and you can say, pick a model that's going to evaluate your results to see if you've got it right or wrong and do a system test and things like that. So you can use models to test models, which is generally what we do. But I'm just going to do similarity and groundedness. I'm going to hit run. And what this is going to do now, again, I've not signed up for anything. I've just got a GitHub account. And it's going to go and it's going to call all of these different models for me. I've not had to set up any servers or anything. This is just working. And it's going to test these results against these different models and give me some answers. And you notice it was expecting New York and actually got back Chicago for 5.3. But notice the groundedness was 0, and as well as the similarity was being 0. So that's suggesting that we haven't given it sufficient context. And actually, if we look at this 5.3 model, the 5.3 model doesn't support passing a system prompt. And that's where I was passing all my data in, my RAG data. And so actually what I need to do is use the user prompt to pass in my data, which is now using up the amount of I've got 8K of context window. That's now using up this window of data I can pass it to be able to make a decision. And so, so, you know, pros and cons of using that model. So maybe I think, well, evaluating this, 5.3 small, 8K is probably out. But actually, like, if I look at the latency, this GPT-4o mini, even though it's a slightly older model, the latency is being typically like a few hundred milliseconds to a couple of milliseconds faster than GPT-4.1. Yeah, I'll just show you. Sorry, I'll zoom in there. You see the latency times? Well, notice it isn't always faster. Like, is on average faster, but not every single time. Again, that's the problem. We're dealing with shades of gray when we're dealing with large language models. We're not dealing with absolute values. It's probabilistic. But I'm doing this evaluation, and I can quickly see that based on my benchmarks, actually, I might be able to, downgrade. I might be able to use a different model to the one I'm using and still have successful results, so maybe I should. So that's cool, and I can let it go through, or I can just hit stop. So that's kind of some of the functionality that's built into this. But let me show you, I talked about this prompt YAML file. Let me explain what those are. If I just go in and look at the code, I've actually stored my personal prompts.yaml in this prompts folder, but you can store them anywhere and it can find them as long as it's got the prompt.yaml suffix in. But this is another important trick that we learned, is to externalize your prompts. So in your application, you're loading your prompt from a separate file that's external to the code. And that way you can be rapidly updating and iterating on your prompts and not changing the underlying code functionality, because the models move so fast that you might want to be tweaking those and tweaking your prompt data while leaving the rest of the application code the same. Does that make sense? Okay, so I've externalized, and if I look at this particular cities prompt, we can see here's the system prompt here, sorry, make that bigger. Here's the system prompt that's coming in. Here's my test data. So it contains all the metadata I need to be able to evaluate this data and be able to do it, as well as the raw prompt. If I look at some other prompt stuff here, we have, like, I pick a different one here. Like, I'll do summarizer, actually. That's giving me an example of doing a JSON feed. When you're calling LLMs, as well as giving it the plan, how do you want to do something, if you want data returned in a certain way, you should give it an example of exactly how you want that data returned. And then using that, it will use that as a basis to be able to give you the answer in that format. So here I wanted a specific JSON feed, so I've told it exactly the style of JSON feed that I want, and then it'll know to return the answer for me. But then what I wanted to quickly do is, a lot of you, who here is using Copilot today to help with their coding? Yeah, okay, nearly everybody. Well, with these, when I start saying about prompts being externalized, people quite often get confused at this point because you can have, for Copilot, you can have a file called custom instructions. So this is an example of a Copilot custom instructions file, which is data that's passed to Copilot every time you're doing a Copilot invocation. This is where you put your coding standards and things like that to sort of tell it how we code in our organization. That's specific to Copilot. That's specific to how you build and develop your application. That's separate to the prompts.yaml, which prompts being used by my application that I'm building. Does that make sense? Okay. So that's how the two differences between those two files. Right, and then the last couple of things I wanted to show you. There's some cool things you can do to play with GitHub Models again. The first thing I wanted to show you was there's a command line for it. So it's just gh models, and I'm going to do gh models list. And we can see in here we've got a bunch of different models we can play with, including the new one today. And cool, that's a lot of models I can just play with from the command line with doing nothing apart from logging on as GitHub. So I can do like gh models run, and then I'm going to say write a short poem. I'm going to get GPT-4 to do that one for me. Cool, poems are great, but actually what I use the command line for most of the time is something like when I'm creating test data to test my application, I'll actually use an LLM to create that test data for me. Here's an example, generate a CSV file. I've given it how I want the answers result in, and there we go. It's now generating a CSV file of data for me to put into my application to be able to test. And so even if you're not building anything to do with LLMs, this is super handy as a raw development tool, because if you think something like Copilot only helps you with development, but you have access to every single model, and with loads, dozens of models that you can play with to use it to help you build stuff and do stuff with your applications. This may or may not also help you do your team's reviews, but I can't possibly comment if that's how I did my current performance reviews for people, but there we go. Right, the last thing I wanted to show you, you can also use GitHub Models during actions. So you can come in here, actually no, second to last. If I come into actions, there's a new query, a new permission, within GitHub Actions. GitHub Actions is the automation platform that's built into GitHub to do CI, but it can do so much more. But as part of that, what you can also do is, you can also set the read permission to on models, and then I can actually call GitHub Models and go make a request within my CI build, for example. So if I wanted it to generate a bunch of test data as part of my CI build, or if I wanted it to evaluate things, I can do that. We actually have a workflow installed in the office, which comes in and issues alt. It comes in, you know how you can like copy paste images into a GitHub issue? Nobody ever puts good alt tags in them, and yet I work with some blind developers at work, and that's not great. And so what we actually have is we make it, if people haven't done an alt tag in their issue that's in their issue images, we will actually use a large language model to go get the alt tag for that issue image to explain it. But because we've got the context of all the issue, and we've got the context of being able to do like OCR inside of that issue, it gives a really good description of what that is a screenshot of, rather than just, this is a screenshot, which is typically what a normal machine learning will do without that context. And I've got time for one more thing to show you, and that is how on earth can I actually do some of this coding when it comes to using my models. So if I go back into my models tab here, we'll notice that down at the bottom, adding AI to your project, how can you do that? How can you get started? Well, it's going to use the power of AI, hopefully, to come back to me with an answer. Wow, that took a long time. There's how I do it in Python to call this particular model, GPT-4o. So I'm just going to copy that. If I head over into VS Code here now, there's my Python code that I've got to call a model, and I'm just going to save it, and I'm going to say like Python test.py. And we'll see from my application, I'm now able to simply call a model, and all I'm using here for now is the GitHub token. So I'm just going to use my GitHub token to just experiment and to do proof of concepts and see how easy is this to integrate into my application. So that's the basics of getting started with GitHub Models. you can grab the thingy if you want now. There you go. That's the basis of getting started with GitHub models. As I say, you're meeting, no more guessing. You're meeting combinations. You're meeting version control with your prompting. But what we want to go on to and show you now is actually how can you go from this experimentation mindset, this growth mindset of like playing with something, and actually take those experiments as proofs of concepts and move them into production. So Facundo.
Let's try to do our best with that. So Martin has shown you basically how you can start thinking about using LLMs into your application. And he also shows the evaluation capabilities that you have in GitHub models to select the best model specifically for your use case. Now, the next step that we need to take is like make our application to start behaving intelligently by using those prompts and customizing them to use in a particular scenario. So let's grab one of the scenarios that Martin was working on and see how we can tie all of these together. Let's see.
You're 3, sorry.
Oh, you're 3 now.
Yeah.
Okay, now I'm back. So what we have here is the Copilot Arrows website, which is the website that Martin has been working on in his repo. So this has a travel guide section that allows you to explore the different cities that the airline travels to and get some highlight information about what is this interested in or some of the things that you may explore in this particular city. So we have also extended a particular feature into this functionality to allow the users to describe their ideal destination, so we can suggest which is the best city to travel to, right? So let's give it a try. Let's imagine that I want to travel to a nice city with beaches and cold weather, and ask for a suggestion based on this particular destination. Did I forget to? Oh yeah. So it took too long. So with this, let's wait for the code spaces to start. But basically, what this is going to return is basically would suggest a city about like where to travel to and based on the description. And something I'll show you in a minute, it also gives you is some hints that you need to take into account based on the description that you gave and the suggestion that you got. For instance, we can foresee here that having beaches next to cold weather maybe depend on the time of the year that you travel to that city. The landscape may be very, very different, right? So let's see how this was actually implemented. Okay, actually, let's hit this again in the meantime. npm run dev. So let's take a look about how this was implemented under the hood, right? So we're here in the repo, and this repository is using Next.js framework with Node.js. Any people from Team TypeScript in the room? Not that many? Team Python? Team Python?
Team C#? My people.
Oh, okay. Okay, I took the wrong language then. Awesome. So what I did in this particular scenario is that I implemented an API that basically takes a suggestion, the description of the best place that the user wants to travel to, and it returns the city or the best city to travel to. Oops. Where's random? Okay. So how this is implemented, basically what we have is this method that uses this service such as city service. And this is actually implemented in two particular steps. The first step is such as the city. So basically, it takes the description of the user and suggests what is the best city to travel to based on the current destination that the airline travels to. And then we have another method, if you take a look, which is explain such as the city, which is used in the application to actually give the user some hints about things they need to take into consideration based on the description that they gave, right? So let's take a look about how this such as city was implemented. So we can see here in the such as city, it has a pretty straightforward implementation. So the first thing that this is doing is actually getting the list of cities that the airline travels to, right? Because we want to constrain the model to only such as cities that we travel to. And then it's using actually the strategy that Martin was explaining to us. Like, it's reading the prompt from within the repository so we can get it inside of the code of our application. And when replacing some of the placeholders that were inside of this prompt with the actual values to complete this workflow. So the input is being replaced by the description of the ideal destination, and the CTLS is completed with the list of cities that we travel to. Then we just make a request to the model, and we come back to the recommendation that we think is better. Something interesting also to notice is that after I get the reply back to the model, something I'm doing is like checking that actually the reply is a city that we travel to. This is a typical pattern that you will see when using large language models, because these are probabilistic systems. So they may make mistakes, and you need to, you have to prepare your code to be ready to handle that if that happens. So this is taking care of that for me in this scenario. By the way, there is a very elegant way to also solve this, which is using structured outputs that is supported in a lot of models that allow you to actually constrain strictly your model to only generate what you are expecting to. So I'll just leave it to you if you are interested in that. So that is how the suggest city works. And maybe you noticed that I was using the OpenAI SDK to make the request to the model. And as Martin showed you before, the way I'm connecting this OpenAI SDK to invoke the model is by indicating the GitHub Models API endpoint, right? And the way that I'm using to authenticate with it is using my GitHub token. And this works because I'm using code spaces, and this embeddable variable is already set up for me. So I don't need to deal with any secret or anything related with that. So as you can see, it's really easy to use GitHub models, not only to prototype prompts, not only to evaluate, but actually to make a real implementation of your functionality and show the real value. But once you start thinking about, OK, let's move this to production, then you start to wonder things about, do I have enough capacity to serve all the users that I'm expecting in my application? Do I have security features that will prevent people from doing prompt injection, from doing jailbreaks in my system prompts? And this is when Azure AI Foundry comes into picture, which is built in with all these functionalities, so you can actually focus on the code and less on the infrastructure, right? So let's take a look about how hard it is to get this same code working now with Azure AI Foundry. So I'm going to go back to my repository, and I'm going to go to the section models. I'm going to scroll down to this same section that Martin was showing you and use this Get API key. We have been using the GitHub free experience, but now in this scenario, I'm going to use the Get Production key. What this is going to do is going to provision an Azure subscription with an Azure AI an Azure AI Foundry resource to back up my solution. And this is the minimum footprint that you need to actually get use of Azure AI Foundry capabilities. We can see also that once I hit that, it's also prompting me to configure GPT 4.1, which is one of the models that were configured inside of my repository. This is interesting also from Foundry because here I have a bit more of control about specifically which model I run in. For instance, I can decide which specific model version of the model I want to use. I can, for instance, indicate which is the right limits that I want to apply to this model in case, for instance, I subject to a budget and I don't want to go over my bill going over something in particular. Or something that I can also turn on is content filter, which basically will put before the request kick into my model some protections to prevent jailbreaks or prompt injections. So for this, I'm going to just leave this as with the defaults. I'm going to hit on deploy. Now that I configure my model, the only thing that I need is an endpoint and keys to get connected to it. You saw that I was using the OpenAI SDK. So what I want to do is to copy the OpenAI URL and the key to get access to this particular endpoint. Let's go back now to our code. In this scenario, I'm going to put like all the secrets in an embeddable .mb file to store all the secrets here. So I say I put them in an OpenAI-based URL, an OpenAI API key. And the reason I took these particular names is because the OpenAI SDK pick up those embeddable variables automatically for you. So actually, in this particular scenario, you don't need this base URL and the API key. You just can comment this out, and that's all the things that you need to switch from using GitHub models to actually using Azure AI Foundry endpoints. Let me go back one sec here. And we all know that, I mean, this was nice, but we all know that taking an application to production takes more than just models and prompts, right? Which is the reason why Azure AI Foundry is actually a comprehensive development platform that allow you to allow the developer to develop with confidence with all the pieces that you need into your application. We have shown here Azure Foundry models. We give you access to a great selection of models, including the one that Martin showed you in GitHub models. We have a bigger selection available there. We also have Foundry agents that allow you to use agentic applications into your workflows, Azure AI Search, in case that you want to do knowledge retrieval into your application, or for instance, content safety, which is the feature that I mentioned before to prevent prompt injection or any misuse of your application, right? Like once your application is out there, like you need to watch out for any possible thing that a user can come up with. But one of the most fundamental pieces about moving to production is actually observability. And the interesting thing about that is that observability is the thing that allows you to explore, debug, and prevent issues from happening by instrumenting your code so you can know exactly what is going on each time that an action is happening there. Oh, there's this one. And the interesting thing also about observability is that the approach, at least that Microsoft has took and Azure AI Foundry has took into this problem, is by implementing OpenTelemetry standards, which is great because developers have the power to select the best framework, the best SDK that they want to use to instrument their code, and then administrators can select the best tool or the best solution to tap into those traces, tap into those logs, tap into those metrics to know what is going on. Of course, if you use Azure Monitor or Azure AI Foundry, we like it more, but you don't need to use them. Like you can use whatever you need. And another interesting thing is like Microsoft is actually one of the top contributors in the OpenTelemetry standard, and particularly in what we call semantic conventions, which is basically an agreement that the entire industry is doing about how we need to log, how we need to monitor specific solutions related with generative AI. And which is also why we're super happy to announce that we're extending these capabilities to also tap observability into MCP servers. I don't know if you have heard about them, but like basically when your LLMs start to need to consume external tools, they need to consume external resources, then the complexity of the solution start to scale up, right? So something would be super interesting is like if you can put all that logic, all those tools, all those resources in external systems, which are servers, and then your LLMs connect to them. But of course, if you do that, like then you need to know what is going on under the hood there, right? So this is why like this observability capability is going to really give you access to know what is going on under the hood in those servers. So let's take a look about how hard it is actually to implement observability inside of your application. So let's go back to the code, and let's go to Azure AI Foundry again. In this scenario, I'm going to explore the tracing functionality in Foundry. And basically, in this scenario, I already also created a project so we can organize all the traces and everything that is happening in my application inside of a project. And this project is connected with an Azure Application Insight resource, which, of course, it implements OpenTelemetry. So the only thing that I need to instrument my code is actually tell my code, hey, send all the telemetry to this particular place. And the way I'm going to do that is like go to manage data sources and copy my connection string to this particular application insights. Once I have that, then I'm going to switch back to my code. And in the same way that we store the secret in an embeddable variable, let's do the same thing with this connection string. Let's put in an application insight connection string. Now we need to instrument the code. And there are many ways to instrument code. In particular, this is Next.js. So hopefully you find it insightful, and now I can convert you from C# to TypeScript. So you can instrument your entire application just by placing your tracing instrumentation in an instrumentation.ts file. So that's all the thing that I need to do to instrument my application. In this particular scenario, I'm using Traceloop, which is an open source library, and it has a really nice implementation about tracing in Node.js. And let's take a look about how this was actually implemented. So the first thing I'm doing is like getting my connection string to Azure AI Foundry. And if you see, I'm configuring an exporter to send these traces to Azure Monitor. Something that I also want you to take notice is that if I don't have a connection string configured, I still configure an exporter to send all my telemetry to the console. And this is really interesting in scenarios where you are doing integration testing or like when using GitHub workflows, like as Martin mentioned, because if you are integrating changes into your code, that code is going to consume LLMs, and you want to know what is going on under the hood. Right? So if you're sending the traces to the console, then you go to GitHub, you see the output of the console, and you can see, for instance, why your tests are failing. Right? Once I configure the exporter, the only thing I need to do is to initialize the tracer. And something interesting that I'm also doing is I'm telling the framework, hey, I want you to type also into the OpenAI library. So I want you to instrument this particular library to know what is going on there. And technically speaking, this is all the thing that I need to do to trace my application. But let's go one step further, right? And I mentioned to you, I didn't show you because the code page was stopped, but in order to answer the user the suggested city, we take this in 2 steps. First, we find which is the best city based on the description of the ideal trip from the user. And then we try to find out an explanation about why this match is a good match and things that the user needs to take into account for this destination. So I want somehow to capture this into my application and tell the system, hey, these 2 steps are 2 parts of the same thing. So in order to do that, what I'm going to do is like go to the suggest city, and I'm going to add the decorator task into the method. And I'm also adding some extra metadata. It's not required, but like I'm just putting a name to this particular method. So this, I'm telling the OpenTelemetry, this is particular task that I want you to capture. And I'm going to do the same thing with the other task, like explain suggest city. So let's see how this looks like in Foundry now. So I'm here again in the traces, and I can see some of the past requests I have been doing to the system, and I see the post to the API service that I mentioned before, right? And this is interesting, right? Because you can see here that a post was made to this backend service, and now we can see all the steps that need to be completed in order to fulfill the request, right? So we resolve some page component. This is part of the framework. But then we can see here the first task that I configure, suggest city, and I can see here the explain suggested task. We can also see how much time this is eating us, right? Because we have the user waiting on the other end, right? So as Martin was saying, be careful when you select a model, because you have faster models, slower models, but also that may compromise the experience that the user has. So this is when you can also put the trade-offs into practice. If I tap, for example, in suggest city, and if I go to the details, I can also see what were the inputs, right? Like a nice city that I mentioned before, and I can see what was the output of the method, not of the LLM. The method that is using LLMs under the hood output this part. And we can see also, as I mentioned, that OpenAI kick in inside of the code of this method, right? So if I select that one, now I can see all the details about this particular LLM call. I can see that they was using GPT 4.1, it has a temperature, and I can see also what's the prompt that was used to prompt this particular user, right? So you can see now how all the pieces, some of them are deterministic because we code them, some of them are probabilistic because we're using these models under the hood, but I can see the role that each of these pieces play together to then come up with the experience that I see for my users, right? So now I can start moving more confident to production because I know exactly what is going on under the hood. What do you think, Martin?
Yeah, no, this is amazing. And I think what this is showing us as well is how we're doing like the whole life cycle, you know, how we're going from development and that fast loop. Like, you know, when you're developing, compiling. With models, you need an inner loop of experimentation and testing, and then you want a wide loop, and then you want to get to production, and then importantly need to learn. And also the fact that you're using OpenTelemetry and like defining actual standards around how we do that helps make sure that all models plug in that way as well. So I was talking with some of the audience as we were coming in, and they're saying about how they're running their own particular models, and you know, so it's a way you can do that as well with other applications.
Yeah, especially when you have a big ecosystem, having semantic conventions to log everything in the same way is critical, because you may use in one framework, I may use in the OpenAI SDK, you may use in Inference SDK, or you may use in any library out there. So it's critical. Yeah.
And the thing I can guarantee you is whatever model you're using tomorrow won't be the same model you're using in 6-12 months' time. One of the things we found with Copilot was you can spend a lot of time fine-tuning on a particular model, but actually the capabilities of the large language models are moving so fast that it pays you to be equipping your applications to be able to iterate more easily to get the latest and greatest models, rather than spending too much time customizing per model. And that's where using prompt engineering comes in. Cool. So if we have a look now, we've got kind of how you do this with application development. As we talk about in that inner loop, you sort of you're in GitHub models, you're experimenting, you're doing rapid prototyping. You can get up and running literally right now. And then it's not that much harder to then get set up in Azure Foundry as well. You press a button, you get a key, and that sets up the infrastructure you need in Azure Foundry. Now, I know we dug into as well, and we can see the sophistication is there in Foundry. Models is going to get you up to prototyping and development and its experimentation. But if once you start adding in the security feature side, protecting your prompts, once you start really tweaking exactly which version of the prompt you want to use, which is something you definitely want to do when you're in production, that's when you should be in Azure Foundry land. Sure, you could take a proof of concept and actually push it live and within limits, because the free, the GitHub model stuff has some limits in terms of usage. You could do that, but what you should be doing is use your Azure Foundry, once you get past that experimentation side. It gives you the powerful services, it helps you scale, and also most importantly, it has that monitoring feedback loop as well. Now, as I mentioned, the GitHub model stuff is in preview now, as of this morning, so that's exciting. We're also, but it is the preview. This is the beginning of the journey when it comes to GitHub models. So what's coming up next? What's on the horizon? We've got the ability to do some additional page. Right now, there's like a free limit, and then you can start to buy additional model calls if you want, or if you want more expensive, bigger, faster models. So bring that capabilities. We also want you to be able to bring your own model capabilities. Again, I was talking with a couple of people as we were filing in. That's something that they definitely need. And then we are currently the industry's just moving so fast right now. Well, we've got the prompt.yaml. That's very much a kind of, here's one way of doing it suggestion. I don't think that by any means is going to be the end of the day when it comes to how prompt files are stored in version control. And so we're experimenting, and we're working with other vendors, and we're working with the open source community and the wider industry to look at more prompt formats, more complex prompt scenarios, and kind of getting those integrated as well. So what you're seeing today is very much, I think, the beginning points is how I would describe it. Obviously, the Azure Foundry side is that much more mature, because it's being used in production for lots of applications, including us. And then as we look GitHub models, if you want to give feedback as you start playing with GitHub models, the team are here on site this week. And then we've got a discussion forum that they're very, very active in as a team. So if you start playing with the models experience within GitHub, find things that you want to change, improve, let the team know, because it's in preview and we want to make it better. And that's why you've come to Build, is to be able to influence how these things get developed and built. And then when it comes into the Azure AI Foundry side, we've got some great resources for you to access. These slides will be available for you as well to access. But the thing I would actually go recommend is exploring Azure AI Foundry. So just go to ai.azure.com. And then also we've got some amazing courses in Learn around some of the AI capabilities. And there are workshops here this week as well. So if you want to learn more, I would actually go take a look at the AI Learn courses and obviously review the docs and read the SDKs and all that sort of stuff. Now, a quick plug for, I'm about to go on to another session where I'm going to chat with a couple of my mates, Dr. Nicole Forsgren and Gene Kim, and we're going to talk about what this whole means, you know, AI to the world of development. So we're going to be doing that later on this afternoon. And then we've got Nicole and Gene are going to come down to the, if you've seen the hub area, the GitHub have an area there. There's a big like Mona cat with blinky lights and things. Gene and Nicole are going to be there and signing books as well. So if you want to pick up a signed copy of Accelerate, you can. Oops, why has that gone to there? And then last but not least, look at this, we did it perfectly. I want to thank you very much for your time, for being here. We've got 5 minutes. If people have got questions, feel free to come up to the mic. But otherwise, I wanted to make sure you got 5 minutes to get to your next session. So thank you, everybody.